morning all. So again on student demand I am generating a short videos on a revision lecture on transformer. As per university syllabus there is a theory part in transformer. So during exam period what you revise about the transformer. So it is a very short theory part of transformer, detailed transformer video, because transformer is a big topic that I'll cover in next playlist. But now the interest is that is how we have to cover some theoretical concept of transformer from Mumbai University exam point of view. So in transformer the first question is always explain construction. It is already happened in 12th standard also. Explain construction and working principle. Construction and working principle of transformer. Construction and working principle of transformer. In that, what you have to write? It is might be 4 or 6 mark question, and it is very straightforward and simple, because in transformer the first important part is the iron core, and that's why I always draw the iron core like this. So this is a iron core. This iron core is made up from high grade silicon steel, so stamping is there. Then one side there is a winding called as primary winding. The winding which is connected to the supply side. It is suppose my first single phase AC supply. So winding which is connected to single phase AC supply or supply side, that winding is always called as the primary winding. And this primary winding is always made up by the copper. So first part you have to show the iron core. Iron core. Second part is primary winding, and opposite side on load side there is a secondary winding. There is a secondary winding, and on secondary winding load is connected. So this is your secondary winding. This is your secondary winding. This is the load. This is the primary winding and iron core. So in exam first you have to draw this diagram, that is a construction diagram of transformer, and explain the three part. That is, first is iron core. Iron core is always made up by high grade silicon steel. High grade, you have to write inside that high grade silicon steel, and basic intention or basic function of this iron core is to create magnetic flux inside the machine. What you have to highlight here, that iron core is create magnetic flux when it is excited, and that flux is called as phi main flux. So this is the roughly nature of magnetic flux inside the iron core. So first part, that is the iron core, it is made up from silicon steel, and basic function is to create the magnetic flux. Second part, that is called as primary winding. So what you have to write inside the primary winding? The winding which is connected to supply side is called as primary winding. It is made up by copper, and basic function is to excite the iron core. Basic function is to excite the iron core so that it create magnetic flux. So this is the second part called as primary winding, and third part is called as the secondary winding. Third part is called as the secondary winding, and the winding which is connected to the load side is always called as secondary winding, and basic function of secondary winding is to satisfy the load requirement, because load is always connected to the secondary side. So when there is a word construction, what you have to write? You have to write the three parameter: iron core, primary winding, secondary winding. Iron core made up, it is remain common for both primary and secondary, made up from high grade silicon steel, and basic function is to create magnetic flux. What is the primary winding? The winding which is connected to supply side is called as primary winding, and basic function is to excite the iron core so that iron core create magnetic flux. And secondary winding, it is also made up by copper. The winding which is connected to load side is called as secondary winding. It is made up by copper, and basic function is to satisfy the load requirement. So this three part you have to explain in this answer, and then you have to write short. You are already aware about the working principle. Working principle. In working principle, what you have to write? Working principle, first you have to explain that when we excite the primary winding create alternating magnetic flux. Primary winding create alternating magnetic flux. Same flux linked by primary, same flux linked by secondary, and there is generation of self-induced EMF in primary denoted by E1, and mutually induced EMF in secondary called as E2. So this is you have to explain in working principle. So I explain again. Once you excite the primary winding create alternating magnetic flux. That flux linked by primary, there is generation of E1, and same flux linked by secondary, there is generation of E2. So according to Faraday's law, there is generation of E1 and E2, but important point, without any electrical connection, we can transfer voltage or current from one side to another side. That's why word is transformer. So the first question in short revision, what you have to write, explain construction and working principle. This is the first question in transformer. Then we have to go for exam point of view, question number 2. This is the most important question, that is derive EMF equation of single phase transformer. Derive the EMF equation of single phase transformer. So this is a most important question always asked in the exam, and that's why when you answer it, first job, that is you have to draw the construction again. So this is the iron core. This is again iron core. On iron core, one side there is a first winding called as primary winding. Same diagram you have to repeat again. Same diagram you have to repeat again. And there is a secondary winding on another side. Practice this diagram again. In primary, you have to apply the supply. When you apply the supply, we know that there is generation of magnetic flux. Show the magnetic flux here. Direction is always clockwise by thumb rule. Generated flux. So first point in explanation, what you have to write, when we apply primary voltage to the primary winding, primary winding generate alternating magnetic flux as shown below. So what is the nature of alternating magnetic flux? This is the nature of alternating magnetic flux. Maximum value रहेगी phi m, नेगेटिव मैक्सिमम वैल्यू रहेगी माइनस phi m, और इसी को आपको डिफाइन करना है इन टर्म्स ऑफ टाइम पीरियड. तो टोटल टाइम पीरियड फॉर वन साइकिल इज ऑलवेज रिमेन t, but in terms of frequency it is become 1 by f. So time period become 1 by f. Then half cycle time period become 1 by 2f. ये important काम आपको करना है 1 by 2f. And quarter cycle time period you have to define 1 by 4f. So when you write, you have to draw this waveform. So first step, when you apply alternating supply, it generates the alternating flux inside the iron core. So once it alternating magnetic flux generated inside the iron core, according to Faraday's law, second step, according to Faraday's law, there is generation of E1 and E2 across both primary and secondary. तो primary के across voltage generate होगा E1, secondary के across voltage generate होगा E2. Now we are interested to calculate what is the magnitude of E1 and E2, and that's why generated EMF is always described by Faraday's law. And what is the Faraday's law? d phi by dt. So what is a d phi? D phi is always called as change in flux. And what about dt? That is called as time taken. So ये इक्वेशन आपको अच्छी तरह से लिखना है. पहला रहेगा d phi by dt, उसके नीचे लिखना है change in flux and time taken. और ये इक्वेशन डिराइव करने के लिए आपको लिखना है कंसीडर क्वार्टर साइकिल. आपको कंसीडर करना है जस्ट 1/4 साइकिल. Now please observe here 1/4 cycle. When you consider the 1/4 cycle, in 1/4 cycle, what is the change in flux? Maximum flux is phi main, minimum flux is 0. So what is the change in flux? Change in flux remain phi m minus 0. Phi m is a maximum minus 0. And what is the time taken for quarter cycle in terms of frequency? 1 by 4f, because entire is 1 by f, 1 by 2f, so 1 by 4f. So here if I write 1 by 4f, then what is the EMF? E equals to become 4 phi mf. But whatever generated EMF, this EMF is always the average value, is called as the average value. And we know that in AC we always use the RMS value. And if I want to convert this average value into RMS value, we have to take support of form factor. What is a form factor for AC supply? It is always ratio of RMS value. It is always ratio of RMS value to the average value. RMS value to the average value. What is RMS value? 0.707. Yeah, you can write like this. That is RMS value equals to KF, that is a form factor into the average value. And if you simplify, then RMS value become, what is the form factor of AC supply? 1.11. And what is the average value? 4 phi mf. So if you simplify, then it is become 4.44 phi mf is the average value of EMF across the winding. But we know that, once again I repeat, when you consider what is the Faraday's law, d phi by dt, so it become change in flux by time taken. Consider the quarter cycle में flux क्या change हो रहा है, phi m minus 0 divided by 1 by 4m, so it is become 4 phi m, but it is a average value. In order to convert the average value into RMS, we take support of form factor. What is a form factor? RMS value by average value. And that's why RMS value equals to form factor into average value. So 1.1 into average value, the RMS value become 4.44 phi mm. If I say primary is wounded with certain number of turns, that is equals to N1, and secondary is wounded with certain number of turns equals to N2, then final expression, that total EMF for primary denoted by E1, that is equals to 4.44 phi mf into N1. ये रहेगा आपका पहला EMF इक्वेशन, और सेम फ्लक्स सेकेंडरी को लिंक हो रहा है, दैट्स व्हाई टोटल EMF फॉर द सेकेंडरी दैट इज E2 इक्वल्स टू रहेगा 4.44 phi mf into N2. That is your second equation, and these both equations are called as the EMF equation of the transformer. So for 4 marks you have to write answer like this. This answer you can get from anywhere, but this is the procedure to write the second important question on transformer. Derive the EMF equation of transformer. Next question in transformer, generally called as question number 3, and this is also important question, that is, what are the different types of transformer? Question number next, explain types of transformer. So there are many types of transformer depending upon turns ratio, depending upon their uses, but if you consider about turns ratio, then first type of transformer is called as step-up transformer. So what is the meaning of step-up transformer? Suppose I use conditions such that my primary step-up matlab secondary voltage should be larger. So if I put the less number of turn on primary and larger number of turns on secondary, then automatically your primary voltage that is V1 is less than V2. So when V1 is less than V2 matlab N1 is less than N2, such transformer is called as step. Please. When V1 is less than V2, N1 is less than N2, then such transformer is always called as step up transformer. So this is another important point, that is a step up. Second रहेगा step down transformer. एग्जैक्टली उल्टा लिखना है. स्टेप डाउन ट्रांसफॉर्मर में क्या होगा, प्राइमरी टर्न्स ज्यादा होंगे, सेकेंडरी टर्न्स कम होंगे. इसका मतलब प्राइमरी वोल्टेज इज ग्रेटर देन सेकेंडरी वोल्टेज means N1 is greater than N2, and such transformer is always called as step down transformer. So according to the turns ratio, transformer get classified into step up transformer, step down transformer. Another category is there, that is called as isolation transformer. In isolation transformer, what will happen exactly? Both the turns are same, that is primary turns as well as secondary turns remain same. मतलब आपका V1 equals to होगा V2, N1 equals to होगा N2, और सच ट्रांसफॉर्मर को कहते हैं आइसोलेशन ट्रांसफॉर्मर. सो तीसरी कैटेगरी रहेगी आइसोलेशन ट्रांसफॉर्मर. इन आइसोलेशन ट्रांसफॉर्मर K always remain equals to V1. What is the generally K equals to basically V2 by V1, output turn by output voltage by input voltage. So here if you think about K equals to, so here V2 is greater than V1, matlab K is greater than 1, and here K is less than 1. So this is the three types of transformer you have to explain. Chances are very less, but by chance if they ask the question what are the different types of transformer, step up, second transformer is known as step down, and third transformer is known as isolation transformer. So these are the three classification you have to explain to answer the third question, that is called as types of transformer. After that, there are fourth and most important question number 4, that is what is the ideal transformer. What is the ideal transformer? ये most important question रहेगा. To answer this question, what is the ideal transformer, just draw the transformer construction again. Draw the transformer construction again, and you have to explain what are the conditions to make any transformer is ideal. Practically there is no ideal transformer concept, it is just imaginary concept. That's why in order to explain the ideal transformer, first important point that there should not be any leakage of magnetic flux. Leakage of मैग्नेटिक फ्लक्स, मतलब मैग्नेटिक फ्लक्स का कुछ भी लीकेज नहीं होना चाहिए. इसका मतलब कोर शुड हैव, दैट इज कोर शुड हैव हाई परमेबिलिटी. दैट इज कोर शुड हैव हाई परमेबिलिटी. कोर शुड हैव हाई परमेबिलिटी. कोर शुड हैव हाई परमेबिलिटी. दिस इज द फर्स्ट इंपॉर्टेंट रिक्वायरमेंट. सेकंड इंपॉर्टेंट रिक्वायरमेंट क्या होना चाहिए आइडियल ट्रांसफॉर्मर में? कुछ भी लॉसेस नहीं होना चाहिए. लॉसेस शुड बी जीरो. ट्रांसफॉर्मर में दो लॉसेस होते हैं, कॉपर लॉस एंड आयरन लॉस. लॉस कुछ भी नहीं होना चाहिए. लॉस अगर कुछ भी नहीं हुआ तो ट्रांसफॉर्मर की इफिशिएंसी जाएगी 100%. सो दिस इज अनदर रिक्वायरमेंट, दैट इफिशिएंसी शुड बी 100%. सो लॉसेस जीरो, इफिशिएंसी इज 100%. और एक टर्म आते हैं दैट इज कॉल्ड एज रेगुलेशन. तो परसेंटेज रेगुलेशन शुड बी इक्वल्स टू 0%. मतलब वाइंडिंग में कुछ भी लॉस नहीं होना चाहिए, वोल्टेज का लॉस. So no permeability, no leakage of magnetic flux, losses equals to 0, percentage efficiency is 100%, and regulation equals to 0. So when any transformer satisfy these four conditions, such transformer is called as ideal transformer. So for 4 mark purpose, you have to write matlab no leakage, core should have high permeability, no losses, efficiency 100%, and regulation should be 0%. So this, when any transformer satisfy this requirement, such transformer is called as ideal transformer. And the last question that you have to prepare in transformer for theory point of view, and that is called as losses in the transformer. Losses in transformer. Basically losses in transformer get classified into two parts. One is called as copper loss, one is known as copper loss, and another is known as the iron loss. Copper loss, another is known as iron loss. Basically copper loss is always denoted by P, that is a power loss in copper, PCU loss, and iron loss is denoted by the PI. Iron loss, तो इसका एक छोटा सा डेफिनेशन लिखना है. लॉसेस इन वाइंडिंग, शॉर्ट में बोल रहा हूं, लॉसेस इन वाइंडिंग, WDG is winding, is called as copper loss, and losses in iron core, losses in iron core is called as iron loss. So iron loss get classified into two parts. One is called as eddy current loss, and another is called as the hysteresis loss. Eddy current loss and hysteresis loss. But iron loss are always proportional to voltage, and voltage always remain constant. That's why iron loss is called as also constant losses. Constant losses. आयरन लॉस नो लोड टू फुल लोड हमेशा स्टेबल रहेगा. लेकिन कॉपर लॉस का फॉर्मूला क्या रहेगा? प्राइमरी करंट I1 स्क्वायर इंटू R1, दैट इज रेजिस्टेंस ऑफ प्राइमरी, एंड I2 स्क्वायर, दैट इज करंट ऑफ सेकेंडरी इंटू R2. तो इसमें देखो कॉपर लॉस इज ऑलवेज प्रोपोर्शनल टू द करंट, एंड करंट वेरिएबल रहता है, इसलिए इस लॉस को हमेशा कहा जाता है वेरिएबल लॉस. सो एग्जाम यू हैव टू एक्सप्लेन लाइक दिस. In transformer there are two losses take place. One is called as copper loss, another is called as iron loss. Copper loss is denoted by PCU loss, iron loss is denoted by PI. Losses in winding is always called as copper loss, so losses in iron core is called as iron loss. Iron loss get classified into two parts, eddy current and hysteresis loss. Eddy current and hysteresis loss are always proportional to the flux density. Flux density depend to the voltage. That's why these losses remain constant, known as constant losses, while copper loss is proportional to the current, that is primary current as well as secondary current, and current is variable from no load to full load, and that's why these losses are called as variable losses. So for 4 marks you have to explain this answer. So it is a short video according to the Mumbai University. What are the 5 questions you have to address in topic called as transformer. Wish you all the best and thank you.